Hi guys, in this video we'll be talking about a problem in triplets. This problem is from the starter 72 from Codechef. The problem states that Alice is still not satisfied with with Bob's math skill, and so she gives him a new challenge. In this challenge, he's given with a positive integer n. We have to find three positive integers a, b, and c such that the product of any of two of these three integers is a divisor of n. Also, the product of all of the three integers should be a multiple of n. If there are multiple solutions, we can print any one of them, and if no solutions exist, we have to print a -1. The input format is that they'll be providing us with a single integer t, that would be the number of test cases. Following that, they'll be providing us with a single integer n t times, that is the integer n for which we need to calculate these values. The number of test cases is less than 100, so that is pretty neat. Other than that, n can go up to 10 to power 9. So let's see what we can do over here. So a trivial observation is that 1 is always a divisor of everything, so 1 can be in our answer, since the answer they are expecting is just positive and it has no constraint that it cannot be 1 or something, so we can have 1 as one of our answers. Secondly, we'll try to find the factors of n. So let's say one of the factors of n was x. N might have many factors, but let's say the first factor of n that we were able to find out was x. So with this knowledge, what we can say is that a can be 1, so the first integer a can be 1, b can be x, and c can be n divided by x. Now why would it satisfy the constraint? So let's see. So the first constraint is that the product of any two of these three integers should be a divisor of n. Now is a into b a divisor of n? Definitely, because x is a divisor of n, as we said. So a into b is itself x, which is a divisor of n. Is b into c divisor of n? So b into c would be x into n divided by x, which would then be n. So n is definitely divisor of n. Every number is a divisor of itself, so that is also satisfied. Is a into c a divisor of n? So a into c would be n divided by x itself. N divided by x, as we said earlier, is a divisor of n, so that also holds. So the second constraint is that the product of all three integers is a multiple of n. So now when we do the product of all of these three integers, it should sum up to something that is n into k. So it should be a divisor of n where k is greater than 0, k is greater than or equal to 1, we can say. So does that happen? So when we multiply these three integers, we get x into n by x into 1, that is actually n itself. So again, every number is its own multiple, so every number multiplied by 1 is the number itself. So we see both of the constraints are satisfied. Now let's try to code it up. So we can say the number of test cases is t, so we can take t, then we can loop over all the test cases, so while t minus minus, and we can say a, b, and c are the three variables. So I have initialized a with 1, let's say b and c are -1 for the time being, just providing them with dummy values. We'll also have to take n, so let's say n is equal to 0, and then let's take n. Now what I can say is that I'll have to try to find the one of the factors of n. So I can go from I is equal to 2 till the square root of n, and then I can say that if n is divisible by I, that means I found a factor of n. So the factor can now be stored in b, and then I'll break, because I just wanted to find one factor. As soon as I'm able to do that, I'll break. So once I'm able to do that, I'll simply check if b is equal to -1. So this would mean this condition never got satisfied. That means it didn't have any factors. In that case, we'll have to print -1. That's obvious. If this condition got satisfied, then we'll be having three variables, so they would be a, b, and c. So c, as we said earlier, would be n divided by b. We'll simply check if b is not equal to c, then we can print a followed by b followed by c, else we'll have to print -1. So when would this particular condition arise, that b could be equal to c? Could it be a case that b is equal to c? It definitely can be in case of perfect square numbers. Specifically, let's talk about 4. So 4 is a perfect square. Its prime factors are 1 and 2, right? So 4, when we'll be quitting 4, we would be having b as 2 as as in the first loop itself. We'll say that 4 is divisible by 2, assign b as 2 and break this condition. Over here, when we'll try to assign c, we'll get c is equal to 4 divided by 2, and c would also be 2. But over here, we have been told that we have to find 3 distinct numbers. So now b and c are equal. So this is an explicit check that we'll have to do. Now let's try to run this particular solution. Okay, so we have received some values. Let's try to submit the code. Okay, cool. It's not accepting the solution as of now, but yeah, this code is definitely fine. I'll try to put the link of this code in the comment section. You can refer to it. Thanks a lot. If you have any doubts, please let me know. I'll try to make a video on that as well.